So I've come to the conclusion that 99.9% of the people of this world are in a deep coma. I'm going to scan over some of these papers that we've already made, drawings we've already made videos on. There's some points right in here to see. You want to know what you're looking at, you can just go watch the video on them. This isn't a new thought of mine. Of many people here being in a coma, but the understanding of that is becoming clearer and clearer for many reasons. Much of what's going on in the world is one of them. Things people say, things people do. It's off the charts crazy. A lot of people know that, a lot of people see that. But the biggest reason I say so many people are in a coma is because even after making the videos that I've made and the drawings that we've produced with the Magnetic Wizard, with the massive amount of information that is on the drawings, in the videos, nearly nobody, and I mean nearly nobody, will even care what is said and shown. They won't lift a finger to investigate and look and see for themselves. Basically do any of the work to see for themselves, to prove to themselves that what is shown is real and correct. They'll go about their day as they always do, believing what they always do, looking to Google for their facts and information from all their experts. Without spending much effort or any effort in determining what the truth is for themselves. That, to me, would be somebody that would fall right into my definition of in a coma. In a deep sleep, comatose by their lies that have been told to them. The massive amount of false information has put them just in a nice deep sleep. So again, these papers right here already have videos on them. Coming up though, there's 3 that do not have a video on them. This is one of them. Try to design these papers as best I can to have it pretty much explain itself, but do my best to explain what it is that you're seeing on these, because they are quite complex. That doesn't mean that you can't understand it. If you want to, you absolutely will understand it. If you want to. If you want to wake up out of your coma. So, I guess I'll scan over some of this paper first right here. You can see these geomagnetic excursions right here. This is the current one that we're in. Started in 1810. And this is magnetic excursions going backwards. Highlighted ones are ones that that there's information that can be found on them, of course, like this one right here. This one right here has no information available on Earth. The light is not focusing in on there. What's happening there? So, we'll go over some of this real quick like this. These are all, you can see these geomagnetic excursions. Again, the highlighted ones right here and the numbered ones. There is information on those. I'll show you that in just a minute. And see these highlighted areas right here that have these numbers on them. These highlighted areas in the blue with the numbers on them. You can see here, you can go around the wheel here. So that's what these are right here. I'm going to go over all this in just a minute, but I'll show you these first. There's those. There's these highlighted numbers right here. And this purple, pink, whatever that is. And I got this much, just the greens, of course, they like one up before, saying before, these numbered excursions right here. I wanted to point something out here that I was just looking at just a moment ago. Is this right here is I'm not sure how this happened, but this stuff happens. This right here is supposed to be highlighted over here at the beginning of this cold cycle here. So somehow it's got right there, but it's in this. That is not it. This is the area that was supposed to be highlighted there. These kinds of things happen on our papers because when they're produced on the computer screen, you really can't see the whole. You can't see the whole image at one time on there with what we have. So that's kind of tough, just looking at little areas and have to move around. So anyway, there's places and things that happen, and they're only noticed once after they're printed, and I can look at them, look at the whole paper in whole, and find these kinds of things. There's other ones that occur. So they're just little things that happen like that. Okay, so we got the green, the pink, the blue, highlighted in these numbers. Alright, so there is this other paper right here we're going to go over too. That has just the same geomagnetic excursion numbers on here. Let's start with this one. And looking over here, check out some of this. Yeah, like I said, some of these print these things and then later find out some new information or little places that were mistakes were made. Not much though. So where are we going to start? Alright, I'm going to start right here. To cut the video for a moment, but decided I'll just get this out of the way. Start right here. This chart right here is, these are sun cycle highs and lows in here. And the original chart in here does not have this right here. We added these lines right here, these red lines coming down, the 1, 2, and 3. These are add-ons by us, just indicating that there. All this is added on there by us here at Magnetic Wizard. Here's the credit and source this comes from. So here's this one right here. Original version does not have these black lines running through here right here. Those are added in there by us. Okay. Here. And also these purple lines are added in here. All this down in here, the 297,495 and the 59499, all this is added in there by us. All this is added in there by us as well. Okay. And here is credit and source. This one right here, the original one does not have these black lines. These are added in by us. And the green line is added in by us. These seasons are added in there by us. So there's credit. This one right here, credit, Jim Slater 307, source. And this one, all is original version of it, except for the 450.75 years right here added in each one of these quarters on this orbital ring. And there was an Earth that was in these places right here. As you can see, Earth here. So there was one, but it was kind of grayish. So we put a blue Earth on there in those positions. The moon right here that we put, we put in there. There was no moon position in the original version on here. So those are added in there by us as well. Okay. And that is all the add-ons on this one. The rest of it is all the original version. Okay. So over here, this one is from Wikipedia. Timeline of glaciation, known ice ages. So, I'll give you a quick, I think I already gave you this rundown on here, but so the add-ins in here for us were these black bold lines right here. Only the black bold lines were added in by us, and also the purple 1, 2, 3, and down here to the 7. This right here is an entirely a original version. We've added nothing to this one. And that is credit and source there. This right here we produced ourselves, and I kind of almost wanted to make a whole nother print on it, but that would mean another trip into town, and I wanted to get this video done today. So there's some additional stuff in here that's been moved around and added to it a little bit. These are all the magnetic excursions on here that happen over on this wheel right here. There's 16 of them. As you can see, the 59499 years divided by 16 equals this in years. That's how much the difference is from one to the next one this way. Okay, 41,116 is from the beginning of the cycle right here on begin cycle Y. Okay, see right there, 41-116 years ago from 2020 magnetic excursion event. Okay, this is cycle begin and cycle end right here. So the these two different colors right here compared to the black and this gray, I'm not sure why that happened either. It's something that's going to be fixed and changed later. Stuff just happens. There's no reason why these are a different color than the rest of these. Okay. So here's the Mono Lake excursion right here, and also this is a combo because also in Auckland there's also evidence of the same excursion right there, and Lake Mungo and the Rockall excursion, also Lake Mungo. This happened. This one has here and here for Lake Mungo, and this Lake Biwa and Helena Pali. There, this Tianche happened right here. We somehow had it calculated in here. This is what I found on one article. It seemed to be right in this area, but later it proved out to be more right in here. So this Gothenburg one ends up between these two, just showing you that that's information that's out there. And then right here, Jordan has information on this. Isn't the information that they have isn't from a magnetic excursion, but it's some zero magnetic field that they detected or found in these pots that were found in Jordan back this time right here, and going back 8 to 10,000 years actually on there. Here's our current event right here. These other right here, 13, 14, 15, and 16 are all in the future from here, so that's why they have no information or nothing indicated there. So being that I'm on that right there already, I'll move over to these. I'll put these up here, I think. And I don't know, these are not set up in any particular order. I just wrote them down as they were. So I'm just going to scan over these, and you can look at them. And this is where you can find information on each one of these events right here that has information available on them. So there's the site to find it, the title of it right there. I put this in your see the chart on the magnetic excursion for these three right here. So you can just see the chart on there. It's a very good chart to show you the excursion time span on those right there. Here's where you can find the Lake Mungo excursion, and these dates right here that they have written, these dates I've written down here are what years that they have listed on this information right here. Okay, and this Lake Biwa. Also, all these boxed in areas is information are years ago that they have listed on their article. There's ResearchGate. There's the title of the paper, title of the article, and here's the Rockwell, 26,500 years ago. Title of the article there. This Tianchi one right here, it has the article is listed at 17,000 years. You can see it right here in the title of the article. Also 17,000, but in the article it has an indication that this happened 15,000 years ago. So that's why it's put on here like this right here. So that's also ResearchGate. And this Gothenburg, 12,400. ResearchGate right there. You can find the information. This one on Jordan, again, it's not indicating a magnetic flip, but basically the magnetic field was non-existent at these times. Also, if you read through the article, you'll see where it says that this occurrence also happened at 7,600 years ago. This is on ScienceDaily.com, and here is information. I think that's the title of it right there. The recordings of the magnetic field from 9,000 years ago. Okay, these right here, these next two down here, field became very weak, among the weakest values ever recorded for the last 10,000 years. And this one right here, these are excerpts from the short pieces of information from the article. So also it says right here, this has also happened approximately 7,600 years ago. The strength of the magnetic field was lower than it is today. So on these three right here, 7, 6, and 3, you'll find that these dates right here, this 41,116, you can find a lot of information out there. There's a lot on these three right here, but especially this one, 41,116. Much of the calculated guess, you might say, or what they have figured out, is that it's somewhere between 40,000 and or 41,000 and 41,500. So it's very close right there. And the Mono Lake is also right in there, 33,000, 34,000 years ago. And then there's, on that one, there's also the Helena Poly. This one's, yeah, this one also falls right in that range of about 18,000 years. And that one. And the Lake Mungo, you can see they have this thing at 30. This is really quite incredible. 30,000 years ago and 26,000 years ago. There's the 30,000, 29,949, Lake Mungo. And then the 26,000 that they say, and there's the 26,000, again, Lake Mungo and Rockall. Let's take a look at the Rockall. This is Rockall, also 26,500 years ago. Pretty incredible. Coincidence? 26241. And yeah, there's there's that one. Yeah, it's Lake Biwa. This is also same time frame as the Helena Poly. This one here, they have listed 18,000 years ago, 18803. Now remember, these excursions happen over quite a length of time, and they move from one place to another. So when they find these magnetic excursions, the time line and the time span in there can be over like 1,000 years. So don't start expecting that, well, this says 18,000 years ago and that's 18803. So anyway, Tianchi, yeah, this one, I already went over that one. Gothenburg, yeah, this Jordan, yeah, the 76, yeah, the set on this one right here, it's got the 10,000 and the 8,000, or somewhere 9,000 in there. That's why this Jordan right here is put right in the middle, because it falls somewhere in there. You can make whatever you want to out of that. But here's this one, the 7647. They say 7,600 years ago that there was no magnetic field, or actually no, that's right. Back up on that. I think they said there was no magnetic field, if I remember right, on the 9,000 or 8 to 10,000 there, but the 7,600 years ago, they also detected a significant drop in the magnetic field there. Right here. So. And then, of course, this one right here, the 210 years ago, is the current magnetic excursion that we're happening right now, which started back in 1810. So that's quite incredible right here. If you look, let's just go back from here at 2020. following this magnetic excursion back in time, you end up right over here in 1810 in this area. Now, yeah, it moved around back over in here a bit, just kind of floating around. Pretty much it just does that. It doesn't stay in one place. It's going to move around a little bit. But right in this time area, same thing as, 210 years ago, it just started to make a straight line going right here. Right in the same timeline. Alright. So we're going to get into some actually even more incredible stuff than that. To me, that's pretty incredible and interesting stuff to find that out, to have that understanding there. I'm going to add a little more here. That we put this together, this list together right here. The reason why you cannot find all these events right here, I have not been able to. It doesn't exist as near as I can tell. It's not anywhere. You can't find all these events that are listed on our list right here. You can't find them anywhere. They're not all in one place. They're scattered around. You find some here, some there, some articles that were written like 50 years ago. So nobody has an article writing about all of these events in one article. Nobody has a list of all these events on one list. They don't exist. That's quite astonishing, really. It really is. So that's why there's this going on in here, because you got to pick up this information from various sources, from various different articles, again going back 50 years ago. It just doesn't, they're not all in one place. So yeah, so here's 7 right here. There's the 7 right there. These are all split up right here. These are all these right here are exactly that length of years apart from each other. The 3,718.6875 years apart from each other. So this is where they land at right here. 41,116 years ago. Okay, there's the 7. And again, I don't have the years for those written down, because you can find them. They're super close to the ones that we have on this list right here. They really fall right in line with it there. So let's see, 6 right here, number 6. And 5, 29,949. There it is right there. And the 4, 26,241. 26,241 years ago. 18,803. That's number 3. 18,803 and 15,085. Oh yeah, this one was written in later, so it's not, doesn't have a. I'm gonna put a number on there. Yeah, I changed it to the 2 one here, but anyway, that's the 2. This one got moved. So they're all on here. To understand what these lines are that you're looking at, where these are indicated. I've already done a video on this. These are all the sun the 594.99 sun cycle. I'm going to show you on that in just a minute, but it's also an eclipse cycle that happens after 594.99 years, which is 18.03 years times 33 equals the 594.99 cycle R. Something to get into a little bit later too. So from here to here is 594.99 years, or 33 again, 33 eclipses at 18.03 years. That is one complete cycle on there. So there's 100 of them. As you can see, there's not this count right here. They go all the way around the wheel, and 100 times. That 100 times equals 59,499 years. Is the total length of this cycle right here, which is, okay, so there were a few things that I skipped over by accident in the previous video. I'll show you this one on this original version of this chart right here. Forgot to mention that these green lines right here, these green vertical lines, we've added that in as well, and the times 1, 2, and the times 3 here across this line right here, we've added this in as well. Okay, so I forgot to mention that last time. Also over here, I pointed this out, and I was looking at it further as to why this happened on here. This right here is not in the correct place, as I mentioned. It's high. This is the beginning of the cycle here. And this also is not the middle of the cycle, which is these, which I did not go over yet, but I mentioned. But these right here, these 2 points are supposed to be the middle of the cycle, such as these right here, or these are in the correct place here. But these right here are not. They're supposed to be right here and here. And this one is in the correct place. But anyways, real quick, the reason why that happened was because we believed that we thought at the time we made this right here, we thought that this ring, this seasonal ring right here, ended here. No, sorry, here. Anyway, we rotated this ring back this way to this correct ending place right here at the 731 million years. When we were doing this, we made this correct change right here on this highlighted area, but we forgot to come back and change these over here on the midpoint and the beginning of the cycle back over here. So anyway, I thought I'd clear that up and explain that right in there, what the heck happened over there. Oh yeah, and one other thing I wanted to mention was that back to the geomagnetic excursion events, locations on this wheel. These magnetic events are events that did happen on Triton 3, on the planet of Triton 3. So whether they happened here on Earth or not, it's anybody's guess. I would say yeah, but so anyway, thought I'd mention that part too. Because as we know that this is actually the T4 FMC 19SW. The reason why it's named that is because of the Triton 4, or the equivalent, what would be the same as the moon. But so T3 is the home planet of the Tritonians, and so this whole entire shadow wheel SW is where all this originates from. So in doing this on here, I'm just making comparisons as to the Tritonian shadow wheel to events that have happened on Earth on the same kind of timeline. So I forget to mention that sometimes when I'm making comparisons from Earth to Triton 3. Okay, if you look right here, this 1, 2, 3, 4, 5, 6, and 7 down here, all in the purple, we was pointed out earlier. And those are, again, these guys right here, right? So, starting from, let's just start from over here where we're at in this timeline. But moving backwards in time, go all the way around this one ring right here. One full cycle on this is one of these cycle ends. It's 2,138,215,563 years. And 1/4 of that is this 534,553,000 year, which is this 1/4 right here from this time right here to, I jumped off there. Let's see, this from right here around to here. So that's 1/4 of the cycle. Each one of these right in here, as you can see right here, it says 1/4 of cycle O. 1/4 of cycle O is the 16 million years. Full cycle of O is 64,794,000. So from here to here is 1/4 of cycle O. 4 quarters, 1, 2, 3, 4, or from red line to red line is the 64,794,000. And there are 33 of those, as you can see right here. Cycle N is 33 of the cycle O's. Okay, so I'll point that out first. Now we're going to take a look at these numbers inside of here. This right here was the end of this glacial period right here, which again was 500 million years, 534 million. That ended at this 731 million 153,461.5, but that's not actually completely correct either, because that's plus an additional negative 41,116 years ago. Okay, so which is actually, as you know, you can see that's a very small amount added to the negative on there. Okay, so back to these right here. It's 1, 2, 3, and on down to 7 right here. If you look at, I gotta spin this around a little bit. If you look at the numbers here, this almost 715 million years, 714954, and the 682557. So this is, of course, the on here is the summertime, and could point this out right here. But anyway, you do have these. This is winter, spring, summer, and fall. Each one of these cycles, and again, these are 16 million years in between them right here, which is again 1/4 of the O cycle right here. So watch this right here, because you're going to see something over these right here, which is pretty incredible matchup compared to the Tritonian on the Tritonian wheel here. 715 million to 682 million. Okay, going back to the Wikipedia timeline of glaciation, known ice ages, we have 715 million years ago. Okay, to 680 million years ago. Number one. 714,954,000 to 682,557,000. Real close match. Okay, let's check out number 2. Move along here. 650 to 617. Miracle. 650 to, well, 635 they have here on Earth. Is what they have listed. But still, pretty close, you'd say. Okay, let's check out number 3. 580 to 547. $580 to $547 on number 3. $585 to $552. Still quite close, off by 5 million years each way, but still it's 5 million off this way, and then 5 million years off that way. The time span right here is still the same of being, I didn't total it up exactly, but it's somewhere about 32 million years in there. So the time duration is the same, but just about 5 million years or so off this direction, 5 million years off that direction on here. And number 4, okay, we're looking at number 4, we got 455 to 423. Okay. 450 to 420. Very close match also. Close match. By millions of years off, but still super close. Alright, this one's a little bit different in here because this one has 3 listed as 360 to 289. That's an interesting one because both of those end up on winter lines on here. So somehow they have that listed as from cold to cold instead of cold to hot. So we have a little bit of a difference in here. And that one is 360 to 289. So 293 to this 358. So they've got it at 360 to the 289 down in here. I'm not sure why that is, what's going on there. You can decide for yourself. Doesn't matter to me one bit. So I put these in here as 5 and 6 because just following the same order here from cold to hot, going backwards in time. Cold to hot. Again, they have this right here listed as a 358 there, or 360, sorry. They've got it as 360. And they have this right here, beginning of this cold cycle, right here at 289. So, okay, this next one, cold cycle on this one began at 34,613,000 on the wheel. They have it listed at starting at 34 million and continuing on. What they say is for Earth that we are still presently in an ice age starting from that 34 million years ago, and we're still in this ice age, or in this glacial period. So again, that's not what it shows here. Starting 34 million years ago, but then we went into, Triton 3 went into spring 18 million years ago and began summer 2 million years ago. Puts us right inside of here. Again, 2,216,000 years ago. Of course, that also, like I say, is an additional negative 41,116,000 years. And the reason why it is that additional is because the wheel right here is set at a 0 point at 41,116 years ago was the beginning of the cycle, or the beginning of, again, cycle Y on in the fall, but it's also the beginning of the entire cycle all the way around. Okay. So that's a bit of a difference in there too. Everybody can decide whatever they want to decide on that. It's a bit different. Show you over here on this a little bit too, where that shows up over here. You can see on here, there's the 34 million year line that they speak of right here. And then right here you can see how it's supposedly, or according to them, we on Earth went through this cold period and then a little bit of a rise right here and then went back even colder here. So that's the same timeline right inside of there. The 34 million year point right here is this 34 million year till the present time. And again on this wheel right here, it would be where am I got lost here? Yeah, this 34 million years right here. So let's see if I can find something on here. Not there. Not there. Yeah. So in this one right here, you can see the 0 point, that black line running through there, right to the center of the wheel. That black line is present time. And you can see the negative 2 million years, meaning that we are in 2 million years into the summer on this 64 million year cycle right here. That's right here. You can see the same right here where it's 2,216,000 years ago was the beginning of summer on this cycle. So again, this point from right here to there, I'll show you this. I don't think it's on the I've made videos on this. You can see this. You can see the 13,982,000 is beginning of fall. So summer ends, fall begins at that 13,982,000. Well, you see it right here too. That's because that's 1/4 of a cycle, right? 1/4 of a cycle. You see that quarter cycle right here, 2,216,000 to the plus, to that's in the negative to the plus, or the positive 13,982,000 right here. There's that same quarter cycle. And real quick, jumping off here, so I'm going to get back to what I was showing you over there. You can see the same thing happening here, right here. You see this 252,870 at the beginning of summer there, and the summer ending at 237,996. 252,870 and 237,996. There's that quarter cycle inside of there. There's the 0 point line, passes right through. So on this cycle right here, summer began 252,000 years ago. And that is, again, right there on this cycle. Okay? So that's the way all this right in here works. Every single one of these numbers is exactly where they belong. Every single number will go to every single other place exactly correctly. In degrees around the circle, and numerally, the numbers will follow this line right here. Each one of these cycles moving right here. 18.03 years, or one eclipse cycle, times 33 eclipses equals the 59499, which I've said before also. That cycle R is also a sun cycle. I'm going to show you that like probably right now since I've got your attention on it. And then from there it's going to go times 100 of those. That's these right here again. 100 of these. 100 of them being from here to there. And then from there it's going to go, that's going to create the 59499. That's all the way around here. Okay, one time. That is the cycle Y. Times 33 is going to equal cycle T. That's the almost 2 million year cycle. Then 30 times 33 again is going to be the 64,974. And then times 33 again, okay, here. So back to this right here, this 59499 on cycle R, which is pretty incredible to see this because, again, 18.03 is the time duration from one eclipse to another on, well, let's say on the Saros cycles, if you're looking at it from Earth, it's 18.03 is the time duration from one eclipse to another on the same Saros cycle number, okay? And if you look right here, again, going back to this sun cycle chart right here, each one of these right here is a sun cycle running through here. They run it approximately 11 years. I believe the actual number is 11.03. That's calculated by the Tritinian calculations. I think that here on Earth they got it calculated at like 11.01 years. Again, Triton 3 is 11.03 years per solar cycle. So pay attention right here, because in 1958, oh, we have them over here. I didn't put them on that evidently, but in 1958, where it has that 1 right there, that's the sun cycle R high. That's also, it has an eclipse right there at that point on the 27F SW01P10. I don't remember. We'll get to the which Saros cycle that is a little bit later. I don't have that right here. Doesn't look like. So that's 1958. The 1810, there's not an eclipse on that one. That's why there's nothing indicated there. And the 1661, there's not an eclipse there either. But you can see the 1, 2, 3 right there that we have on there. There they are right there, the 1, the 2, and the 3. Again, this is an eclipse time right here. They are not a perfect match right here. This is off by about 6 months from when, let's just say they have this high right here pinpointed to somewhere around in March or April. The one right here, this eclipse right here, takes place in October. So, again, make of that what you will, but they're right there. And these are not, these points right here are not guessed in here at all. Our lines that we've drawn in here, the way we've calculated that is by measuring the distance in millimeters on the computer from 2000 going back to 1600 on here, and then divided that by those number of years, or in this case like this 400 years. Take those millimeters and divide it by 400 years, and then working backwards from the 2000 back to here in this exact time to right here, puts it exactly right here. So these lines are not just approximated in here. This is an exact point in this number of years right here. This comes out to 1958, essentially 0.78 in the years, or October 19. Yeah, it's October. It's in October 1958. And then right here is the number 2, which is 810, or 1810. Passes right through there. Again, that's not an approximation. It's exactly calculated, the exact distance in the number of years from this line to this line, and that line is calculated exactly correctly from the 2000 line. So it lands right there, exactly right there, and that right there is 1/4 of the 59499 years. Okay, reminding again that that is cycle R here, or 33 of the cycle Ks, or one eclipse to the next on a single Saros cycle of 18.03 years. So there's 1/4 of the cycle. And another quarter cycle back to the number 3 puts it right here. So that looks pretty close to center inside this minimum right here. Not quite exact center as this one, but pretty close. So this comes out to 1661. That is, oh, it's hard to work in here. 1661. See listed on number 3, sun cycle R low. Okay. And of course, all that, those two right there come out to 1/2 of the cycle, or 297.495 years. Okay, so from there I think I'll move on to this right here. It's also another incredible showing what this is. These are also solar cycles, but not in the form of a single solar cycle. The creators of this original version of this chart right here, you can see the blue lines right here. These blue lines represent this time span across here, essentially the recorded. You can see it ends slightly past the Maunder minimum right here, this point right here. This line right here that we have drawn in is the 1661 line. That is this one here. So you can see beyond the 1661 line, or about somewhere back in here at about, I don't know, 1625 or 1610 or so. You can see where their blue line right here ends, right there. So anyway, the blue line represents basically this whole recording of the magnetic sun in its sun cycles right here. Beyond here, there's no recording of it, and even from here to here, it's not. The records are not all that great. The records didn't start again on this point. On this one, didn't start keeping good records of this till somewhere in here. For at least that's from my understanding of it. So, okay, so there's that. The red line right here, I'm not absolutely certain either of how they calculated these, but it has something to do with recording the magnetic output of the sun on the Earth. How they did that, I'm not sure. So anyway, this is what they have found is this. That's what this red line is. So leaving off from here of actual recordings of the sun cycles, this takes over, or right through here on a different record system right here. So yeah, it's getting warm in here. All right, so you can see right here the 594.99. That's that point right there. Same one we were looking at right there. As you can see, and again, this is not guessed in here, even in the smallest amount. We did the same thing where we measured across this chart from 2000 going back to the 0. I don't know where we moved it to. Anyway, there's 200, the 0 point back in here. But anyway, then it's the time, the number of years passed, or from here to here, or from right there to the 1958 October eclipse that occurred right here, against measured right there to that exact point. Not guessed in there. And an absolute miracle, you go 594.99 years back exactly. And holy smoke. It was still right there. And you can see on the same thing here, this is the 1661 low. That's this point right here. It's inside of this low point right here. And this is the 1810 low. It's directly right on there. Here's all the quarter points right in there. And this right here, moving back here further, you make of it what you will. Of course, it's moving back further. Generally, not always though, but moving back in time, things get a little bit more distorted as far as a clear view of what's going on. So we put in these times 1 and 2 in here because there's a cycle period that happens inside of here that seems to duplicate itself, or times it's one cycle or 2 cycles together, or in some cases 3 cycles together. And this is an interesting thing I discovered in here, drawing some lines and looking at something in here. If you look right here, what's going on in here, this is a 0 point. You can't really see the 0. These end up really small in here. You see that 0 right there at the top of that purple line. This is some kind of a 0 point inside of here, and another cycle that runs through here. As you can see right here, going backwards, there's this 1, 2, 3, and 4. If you look over on the other side of the 0 point, it has another 1, 2, 3, and coming up in the future, 4. I'll hold that right there, you can see that. Anyway, make of it what you will. That's what it's got on there. We did put these in here also. Yeah, there's the 1958, October 12th is what it is. There's the Sorrow Cycle number 133. Check that. Certainly encourage you to check everything on here. You'll find nothing in here is wrong. Some places, some things might be like you said, like this situation over here. There might be some things that we just placed in here. Alright, so we also have these volcanic eruptions. Found this to be kind of interesting that these all end up, some of these quite large volcanic eruptions. The 1883 Krakatoa ends up on these yellow lines right here. Yellow line goes right there, right in this low. We have this the 1815 Tambora, gigantic volcanic eruption right there. We have the 1660 Long Island. There's also a very large volcanic eruption. That one goes to, here. It actually lands right on the purple line right here. Oops. You can see we just put the yellow barely right there because it's exactly in line with this right here, or very close. This is 1661, this is 1660. And this is quite incredible too, because these both are very large eruptions. And they both happened, you can see, 5 years apart from each other. There's the two yellow lines right there, 1458 to 1453. Puts them both right inside of this low right here. So again, this is this 1363, October 7th, partial, yeah, question mark. You'll have to figure that one out for yourself because, yeah, partial solar eclipse, Saros cycle 133. The same Saros cycle as this one over here. It's just 594.99 years. And again, that's 33 eclipses apart from each other right here. And so if you look at this date right here, you'll see something on here. I have to point this out. It's a real hassle to have to point this out all the time, but it needs to be said pretty frequently, if not every single time that this occurs. There's a 10-day skip in time, you might say, where there's a calendar date change back in 1582. So there's a 10-day difference in there. But this right here, as you can see, because the 594.99 would be 3 days short from this time, from this one to this one, would end up 3.65 days short. But you can see that it's 5 days long, actually, from the 07 to the 12 right here. It's 5 days long, not 3.5 days short. So I've already made a video explaining this problem in here that goes on between the 1582 and another problem that shows up that I don't have an explanation for. And I don't think NASA does either. So there's something happening inside of here that's not okay with the times given on October 7th for this eclipse to happen right here. So anyway, I made a video on that already. I might insert that little clip inside of here somewhere, I don't know. But anyway, that's something that, again, other people can go and investigate these kinds of things, and they absolutely should. Look for yourself. Please. My God. Look for yourself. Figure it out yourself. Alright, I had to stop the video for a little while. I just didn't even remember that I had this already written down right here on this very paper that I'm going to be going over in just a little bit in this same video. So this isn't exactly the same because, again, that last time duration that we're looking at was the 594.99 years, but you can see the same problem occurring right inside a year. These right here are the 450.75 year time durations. Again, I'm going to go over this in a little while, but you can see this for right here, right now. Right here, 1629, June 21 to 2080, March 21. That's exactly 25 eclipses on the Saros cycle 121. That's the SC there, obviously. And the time duration on that is 164,633.3479 days. And this is using the calculator.net time duration calculator. So that's the correct number of days for one of these cycle periods, which, again, I'm going to go over that later, but this still shows you the same problem that occurs inside of here. And it's very frustrating because it's easy to look at and go, nah, see, it's wrong. Well, no, there's something else going on here that's wrong. So right here is Saros cycle number 137, 1569, September 10th to 2020, June 21. That comes out to 164,643.41 in 8 days. That's 10 days longer than this one, and that is still correct because, and this only happens, again, says some of the 450.7 time durations below have an extra 10 days. This is due to the 1582 calendar date change, right, of an additional 10 days. So the 164,643 and some change minus that 10 days comes out back out to the 164,633 days, which is correct there. Okay, but sometime prior to the 1582, I don't know when this starts, when this began. I've not tracked this, what's happening. Let's just say this problem. I have not tracked this, where this begins, where this situation begins at. So this rate here, where on Saros cycle 131, and this will happen on, as near as I know, every single one of these Saros cycles, not just here. Every single one of them starting at some period. I'm not sure. Somewhere after the year 1300 to 1400, somewhere in there. But here you have 1197, September 13th to 1648, June 21. The time calculator comes out to 164,640 and some change in days. So as I've written here, for reasons unknown prior to 1582, sometime, again, I don't know when, there are 450.75 year time durations. And stop here real quick, because that's not only for these 450s, as I was just pointing out, that the 594s, 594.99 year cycles do that. And so I don't know where, I don't know where this problem begins. The 450.7 year time durations that have an extra 7 days. An extra 7 days in there. So how many of them are there as unknown? So they come out to 164,640. That's right there, minus the 164,633. Right, the correct number comes out to an additional 7 days. Well, 7 days is not 10 days from the 1582 calendar date change. So what's going on there? I don't know, but I'll bet a lot of people would be very interested in knowing that right there. All right, I'm trying to get back to where I was. I want to get this video done. So I'm gonna have to stop. Okay, I'm gonna jump over onto this right here, show you this. You see this 67 million year marker on this summer line, 50 million, almost 51 million right there, and 34,613,000. You have summer, fall, winter, spring right here, and then back to summer again. I went over some of this a little bit. I can't remember what all I covered on it, because somehow I got over onto there with this from one of the other charts over here we're looking at. But I don't think I covered this part of this right here. Again, this is a zero line, as I pointed out on that other drawing. The zero line passes right through here. So on here, this summer began 2 million years ago. Everybody can make whatever they want to out of that, but I'm going to show you another incredible thing, as I was showing before, with this 34 million year cycle, according to them, beginning here and still in an ice age, according to them, to where we are here now. Completely bypassed spring and the beginning of summer right here. So because this is negative 2 million years, or we're into 2 million years into summer here, that's going to be this 2,216,000 added to the 64 million year cycle right here. So that 2,216,000, as you can see, is 67,010. Anyway, the 2,216,000 plus the 64. No, the whole entire cycle, 64,794,000, is this right here. Okay, so you look over here. Again, we drew these lines the same way. I'm going to mention it again because these are not approximated in here. They're measured and put in exactly where they go on the on this timeline right here. We measured them on the computer on the length of this graph, and then measured them in their distance in millions of years across here to this point. So we'll start back over here. You see this right here. You can see again. It just have to tell you it's looks like but it's actually measured right here. But you can see where this is landing at about 18 million years, 15, 16, 17, 18 million years right there. I'm gonna go back here and look again. There's the 18,414,000 spring line. There. Again, we drew this in here as a spring line that would actually be a real spring line on Triton 3, but Earth has a different plan. So there's the 18,414,000, I think it said over there. And then moving on over to here, you can see that that's landing a little bit more than 34 million years right there. There's the 34 million that they say to present of an ice age that we're in. 34 million, I just went over this already, 34 million years ice age. Completely bypassing spring and no acknowledgement we have no summer here. No summer here. No spring. Just winter for 34 million years. So there's the 34 million year marker, or the beginning of winter. This looks like it's about 51 million years. Let's go check. Where are we at? Hey, negative 50,812,000 years. Right there. And look where that goes to. Right there. And real quick, it's kind of interesting that they have this global temperatures over the last 65 million years. 65 million years, that seems kind of familiar. Cycle O. And again, over here, their chart actually, this thing actually, because it says 65 million, it ends right there at 65 million years. But like I had already pointed out before, we're actually 2 million years into summertime, so that's the 2 million plus the 64 million. And some change on both of those comes out to the 67 million year point right here. And so that's why we have our line right here. Okay. So, yeah, make of that what you will. There's the Earth version. And there's the Triton 3 version. What am I looking at there? Alright, good. Got that out of the way. Now there's still a ways to go. I'm going to show you still, just on these papers. Just so you know, because I'll probably forget, I have loads more. Loads more. This goes way beyond these papers right here. None of them are even in the videos. This goes way beyond all this. Yes, it does. Alright, okay. We're over here, I think. These over here, I haven't explained this stuff in here. Yeah, here is the end of what is called the last ice age. that on this wheel right here ended 11,366.5 years from 2020 marker. Okay. So, and the midpoint in the cycle was right here at 18,803 years ago. The beginning of that cycle on the wheel was 26,000 years ago. But not on Earth. The beginning of this cycle right here was 115,000 years ago, according to them. You can check that out yourself. So there's that. Oh, better show you these points on here. There's the 11,366 marker years ago from 2020. It's on the 50, right on the 50 line. Yeah, each one of these is on their quarter markers, so that's yeah, 50. So that's on the half line from the fall line across the wheel over here. See the 100 there. So there's the 11,365. Again, that's the beginning of spring on cycle Y. So that was the end of this cold period right here. So this 14,000 year cold period right here, 1/4 of cycle Y. This 14,874 year cold period ended right here on cycle Y springtime. End of Ice Age. Middle of Ice Age, 18,803. Beginning of Ice Age, 26,241 years ago from 2020. And had a magnetic excursion, which let's check. There, that would be the Rockall and the Lake Mungo. That's not the only one that makes the alignments in here. There's a lot of different things that align at the same time, happen at the same time, including planetary alignments. On Triton 3 anyway. What anybody wants to say about it on Earth, well, you say whatever you like. Alright, so there's that. Oh yeah, this is a good one too. The 784,853 year, which is the cycle T, that was the end of that glacial period and had a geomagnetic reversal. I don't have anything over there on that, but you can find that. It's really easy to find this out about the geomagnetic reversal at this time. I believe the time that they say was 780,000 years ago. Okay, and that's well, right here, the 743,737. And again, this is, like I say, these have to have the 41,116 added to them. I purposely made this chart that way, so there's no mistake in there or error. I'll repeat this again over here. You repeat all this stuff over and over. That this right here, this timeline right here, or the 0 point on this line, is actually 41,116 years ago, which was the beginning of the cycle. So this whole chart is purposely made that way. So when I say it's plus or add an additional negative 41,116 years, is because of that reason. Okay, so the 743,737 here plus an additional negative 41,116 comes out to 784,853 years ago. Okay, was the end of the glacial period and geomagnetic reversal. Okay, so here This one, I don't know. I think don't think this one. Yeah, the end of this glacial period on cycle O. There's not a lot of info on that. I'll have to check again on that one. But in any case, the cycle O has a negative 18 million plus the 41,000. So you get 18,456,000 on the cycle O. That's right there. Okay. So I have the 5 there. And real quick here, I know I got to do the 6 there, but all these are put in here as 1, 2, 3, 4, 5, 6, and all colored like this, so that people can follow what I'm doing right here, even though it's pretty chaotic and there's a lot involved in here. But later on, somebody can, you know, find these places themselves on the wheel a lot easier. Right? Just have to match from here to there. Find the 3 in the blue, right? Find these numbers right here in the blue, and find these numbers over here in this purple, pink, whatever, right, belongs over there. You can find them over there. And again, the green and those in the magnetic excursions, that's why they're that way. And so, okay, back to 6 here. Here's the this one right here. We already showed you that one, but I'm going to show you again, because right here you get the 731,153,461.5 plus an additional negative 41,116 comes to 731 negative 731,194,577.5 years ago was the end of that, which goes back to here. There it is. 6. Okay. I don't think I showed you these right and put the camera right onto these right here. There's the cycles right there. And you can see where it actually spells, well, Crichton right there. There's a story behind that you will have to catch in our other videos. And there's the quarter cycles. I'm going to show you this again right here. You can see these going across there to the cycle N. This right here is a whole another thing to jump into, but you can see this right here for now, showing you that the time span on this 01 segment number right here, which is this right here. See the green lines and the 01 right there? All those lines in this whole segment right here is this right here. And so these have, this is shadow wheel number 01 on the wheel. There's 33 of them. And so this right here is SW01, shadow wheel 01, P02, or go down here, you can see the first one actually right here at SW01, P01, P02, P03, P04, okay. Time duration from one end of the segment to the other is 1,803 years. And this has to do with the eclipses on here. So, well, this right here, this 315 is the distance in years from right across this blue line. So it's 315 right across this line, or from there to there is 315 years. Okay, and it's very nearly exactly 315 years. This distance, this right here, is exactly 1,803 years. But these distances right here are not exactly. They're off by, let's just say, several hours from these times right here, 315. From this point right here to here is 19 years. From here to here is 38 years. This is 296 period. Again, these go from this line to this line. It's not from here to here. It's from here to there. It's the 296. The 315 is also going to be from here to there. It goes straight across here, and the whole wheel does, the entire wheel does that all the way across here. When you do that all the way around this entire wheel, exactly like that, you will end up exactly with there 59,499 years on the cycle Y. Alright, so I think I showed you this before. I don't know what. You see the end of the glacial period here, 11,366 years ago. That goes over to the cycle Y spring. Summer begins in 3,500 years, 3,508. You can see right here also, keep going back to this, the cycle Y fall was 41,116 years ago from the 2020 June 21st solar eclipse. That is again on cycle 137. The FMC 05 M P07. Also, that right there, to understand that, you'll have to catch some of the other videos. I'm not gonna make a 5-hour video here. All right, so holy smoke, I think I'm done with this paper right here. Yeah, with that paper, because now we get to get into this. And this is another absolute mind blower of what this is right here. The only way you will believe it is, and same thing with all this, is if you go check yourself. Jeez. Alright, so this paper has basically the same title and everything on it, just the version B. The other one was the A. So let's point out some of these right here, hit some of these places. Right here we have the 2020 June 21 Northern Hemisphere summer solstice. Now, this wheel right here has been rotated from what this one is. You can see the 47 over there. That's because time-wise and moving in time, that's how this would appear to be over here. But as far as its actual eclipse location, in alignment with these quarter markers here, these seasonal markers, that this eclipse did not happen right there. But both of these are needed to show different things that are happening inside of here, because this one right here can show very clearly, again, from a starting point right here, moving back in time of where this would be on a time scale. But as far as in the actual eclipse landing place, that's not where it is going to land. It's going to be right over here. It's going to land right on this fall line right here. And that's why this one right here is rotated to the fall line on the 2020. Because now this one right here, this paper, will show the exact places of where these eclipses fall at. In relation to these points right here, which is real close so you can understand what I'm talking about, because this is going to be we're going to move between this one right here and this right here, showing this a lot, because right here is the North Summer, meaning the Northern Hemisphere summer right there, Northern Hemisphere summer solstice. Those are going to land right here. And that's what this is right here. Here's the summer solstice. the winter solstice, the fall equinox, and the spring equinox. And I'm going to probably just be jumping around on stuff on here because there's so much on here. We'll point this out real quick. As I said before, these 450.75 year indicators in here, we put those on that line. They're not from the original version of this chart right here. The original version of this shows this in one single year. This will go one orbit around the sun is 1 year, one of our years here. And the Earth and the Sun on summer solstice will align to the galactic plane right here. As I've said before, we put an Earth here, but right underneath that Earth, you can go get the original version of this, and you'll see that the Earth lands right on the line of the galactic plane on the summer solstice, and on the winter solstice, except it's on the other side over here. And then you have the fall equinox and the spring equinox. So, as I've said before also, we put the moon in on these locations right here. These were not there originally. I think I forgot to mention that. Yes, that moon right there and all this right here is in the original version, the original drawing right here. So, what happens every 450.75 years on every single one of these sorrow cycles? Okay, so for sorrow cycles, those 19 that I was speaking about, you see them right here. There's the 125, the 135, the 145, and the 125 will begin again down here. So starting on the count right here, you know, 125, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11, 12, 13, 14, 15, 16, 17, 18, 19, and then back to the 125. So there's 19 of them. And I better stay over here. I'll get back to this over here where I'm showing you, because they're both related together right here. As it says down here, all dated green lines above the northern hemisphere winter solstice solar eclipses on Earth. There's all dated green lines above are northern hemisphere winter solstice solar eclipses on Earth. So these right here are not dated because there's not a solar eclipse that happens on here according to NASA. These sorrow cycles have not even begun yet. Okay, they're too far back in time. According to NASA, they don't exist. And these don't exist, all four of these. But they start to exist here in 1080 and 1099, but then not here. We have one 1452, 1471, not here. As we get closer to what I call our now time, a miracle occurs. You start to have these eclipses show up right here. I'm going to show you why that's a miracle. These four right here, in 1824, 1805, 1824, 1843, 1862. Again, remembering these are all northern hemisphere winter solstice solar eclipses. Okay, they occur on winter solstice in the northern hemisphere, and it's a solar eclipse. What happens on winter solstice? Right here, the Earth and the Sun are in alignment with the galactic plane. What happens when there's an eclipse? The Moon is between the Earth and the Sun. on winter solstice eclipse. All of these dates right in here happen just like this right here on the galactic plane. And going to again to the now time, we have these actually occurring. And again, according to on Earth, according to the star cycles numbers indicated here. And we even have more of them occurring in the year 2177, 2196, and 2215 in the now time. But then they disappeared. There. They are right there. You move down here further and they will again not be there anymore. So they move from non-existent into existence and then back into non-existence. These right here, all dated blue lines above, are Northern Hemisphere fall equinox solar eclipses. What happens on the fall equinox? Right here. Fall equinox, the Earth is right there. And what happens when there's an eclipse? Well, the moon is between the Earth and the sun. Again, all these dates right here. Okay, going back to here, non-existent on these star cycle numbers. Repeat again, they're non-existent because they haven't come into existence because the star cycle has not even started. These star cycles have started and they are on the fall equinox line. Non-existent. Starting to come into existence here more. Non-existent. Coming into the now time. They're all there. Almost all there. Missing one over here. Start fading away. One there. Three not. One there. And then beyond here, non-existent. Alright, moving along here. All dated green lines above are Northern Hemisphere summer solstice solar eclipses on star cycles. All the dated ones. 1276, we have a summer solstice. Moving forward in time, we have 3 show up, but 1 not. Moving into the now time, 4. Right there. Still pretty much in the now time, we have 3, minus 1. Minus 2, have 2. 3, non-existent. The rest down here are non-existent. What happens on the summer solstice in the northern hemisphere? And by the way, anybody that doesn't know this, which, you know, probably a lot of people don't know, but northern hemisphere summer is winter for the southern hemisphere. Okay? But anyway, we just work with the northern hemisphere because that's where we live, so that's what we got. So anyway, summer solstice for the northern hemisphere. What happens on summer solstice? The Earth aligns with the Sun on the galactic plane. What happens with the solar eclipse? I know I'm just repeating all this stuff over and over, but that's the way people understand it better. Just repeating it over and over. What happens on a solar eclipse with the Earth? The moon is between the Sun and the Earth. An eclipse on summer solstice. Right through here. Go back here. Not there. Okay. And still over here. Again, all dated red lines above are northern hemisphere spring equinox. So now this is into the spring. these here are, they all exist. The moving backwards, I'm not sure if some of those exist back there or not right now. I'd have to get another paper. Yeah, I had that right around here. I can't find it now. Anyway, because as you can see right here, this is in the now time right here. So there's probably some, maybe one or two back here that exist. Back here, moving backwards. In the now time, we have all three of these that show up. All four of these, two that do not, then two. Two that do not, and two that do. Four that do not, and three that do not, and do not. Now, again, you throw over here the spring equinox, there it is, solar eclipse, okay, happening just like that. And I understand why there's like a whole bunch of them right here that don't, and this, you know, this goes way up in the future right here. Obviously, this ends at 3/28/62. The reason why that it is that way is because you're moving across here in time in order to keep this all uniform across here. You know, starting back here, you're going back in time quite a bit, because going from here, according to this solar cycle right here, is a non-existent one, but going up 450.75 years, still non-existent, but going up another 450.75, not there, but now it is right here. So what I'm saying is that this is back in time quite a bit further, and now you're moving up in time, so you end up over here up in time, and to go back in time more, well, we'd have to go a lot more back here in time, and then you end up with a bunch of non-existent ones back here showing up on what we've created right here. So just giving a little explanation of why those are not shown on here. It has to do with moving across here at this 450.75 on here. So explain that in there a little bit further. Let's just move up to here so you can see in closer to a now time, like let's say right here. This one right here would probably be a good example, because that one's, see, that's the 123. It still doesn't show over there. But anyway, right here you can see, let's go over it from right here, 1862, 450.75 years. Is going to land to right here at this 2313. And these are the same solar cycle. So this is moving 450.75 years on the same solar cycle, 149, to 450.75 years later to the 2313. And then from the 2313 moving 450.75 years, it's going to go to this 2764, which also exists. So check again. 1862 has a winter solstice solar eclipse. Yeah, a winter solar eclipse. It's going to go winter. 1862, 450.75 years. Into the future from there is going to be 2313. It's going to go to a fall equinox. Now, you look at these and you go, well, they're moving backwards. Well, yep, they do. That's what they do. So anyway, on this, they're moving, going 450.75 years, they're going backwards. Because if it was 451 years or a quarter year extra, well, it'd end up in the same place exactly every single time. So the creator created it to, well, do exactly what it's doing. It goes backwards. It lands 1 quarter short at the 450.75. It's going to land right here. Again, 451 would be in exactly the same place. But it's not. It's a quarter year short. Puts it right here. Just give you that understanding there. So, where the heck am I? Right here. 2313, now it's going to go 2313 to another 450.75 to 2764 on solar cycle 149, and that is now going to move to a summer solstice. It's going to go from the fall equinox to the summer solstice eclipse right here. And then it's going to go back to the spring equinox over here on an eclipse 450.75 years. At least on Triton 3. On Earth, let's check it out. 2764, 450.75 years. Not there. You can follow any one of these. It'll show you the same thing. I'm not going to do any more of them than that because, well, you can check yourself. I'll go down this way first, real slow, carefully here so it's focused, and you can stop it wherever you want. Here. Anybody that's not thoroughly shocked at what I just showed you, well, you're in a deep coma. If you keep watching, maybe you'll come out of your coma. If you're insulted by that, I'm sorry, but that's just the reality of what it is. I already went over these things right here. This is really highly questionable right here. This event, these things that happen right here, or these 450.75 year time durations end up with the 7 days right here. And is not explainable. This 10-day gap right here, or this 10-day difference right here is explainable from the 1582 calendar day change. And the real correct time duration from 450.7 for the 450.75 years is 164,633 and 1/3 days. That's some incredible stuff right there. No doubt. So, I didn't show you on the wheel right here. Let's check this out, and I think I'm almost done with this video. Good thing too. Here are all the, these on the 47, right over here, right, which is the summer solstice. Okay. You can see the North Summer. It's like a white ball. These right in here are all the same ones that you're looking at right over here on the 47. Okay. You know, you never believe it. You know who I designed this, but I didn't do any of the, I've mentioned this before, but I didn't do any of this on the computer because I don't even know how to use the computer. I don't. My son, he's only 16 right now, and he did all this. I'm sitting there with him on most of it, and he has done all this work on here on the computer, and then he puts it on a PDF for me, and I go print it in town. And it's quite amazing. We did this right here. I explained to him what I wanted to see. He understands everything that's going on with all this stuff too. He's 16 years old. He's been helping me with it. Both my sons have been helping me with this for the last, while. He's been working on a lot of other stuff too. But anyway, he put all this together right here. I explained to him what we wanted to see, what we wanted on here. And he put this whole thing right here together. Right here, all of this. Plopped it on there and said, okay, there it is. 16. Okay, so there's that. I got off onto that because I myself was impressed that he turned this right here, these 4 places, the 47, let's look at the 31, the 47, the phone's telling me I'm going to run out of time, the 47, the 63, and the 13 right here. So, that's what these 4 rings are right here. They're 4 seasonal rings, 1, 2, 3, and 4. And so there's the 47 right there. Probably not going to do this in order. I just want to get finished with this. So here are these over here on this cycle. Or in that season anyway, I mean. Here are all these. And those there. So again, all 4 of those is this right here. And I think that's about it. Sure, there's more, but I covered a lot. Thanks for listening.